Today, like I said, we're going to be talking about a little bit of glove safety and a few different things. But before we get into that, I want to ask if you guys see anything here in the shop or in the field that you think should be discussed as far as safety and health is concerned.
I think we're pretty good right now.
Good. Everything's perfectly safe? Good. That's what I want to hear.
We're progressing in the right direction.
Good. Good deal. All right. So part of glove safety, which is going to be our first topic today, is just well, first of all, I guess we got to go over a couple of the generics here. Make sure your cell phones are off or to vibrate. If you have to take a call during the class, that's totally fine. Just go ahead and step outside. Emergency exits. We're going to go right out here through these doors. Straight downstairs out the front door. For whatever reason, if there is an emergency on this side of the building, we would actually exit out this way and out through the shop doors. So that's the plan there. The attendance sheet is being passed around, so go ahead and make sure you get on that. If you're watching this video online, just note that at the bottom of the video there's going to be a link for a test. You'll make sure you want to click on that, complete the test, and hit submit, and you'll get that completed. All right, so the agenda today, like I said, we're going to talk a little bit about gloves and hand safety, as well as type of gloves, edge safety, working in heat, which goes a little bit on the fatigue management side of safety, which are definitely important things to be talking about. Also, you have a little bit of other things going on in the field. All right, hand safety. There's many different types of gloves out there. Does anyone know what type of glove this is?
X-Armor.
X-Armor there.
All right.
It's basically an impact glove.
It's an impact glove. What's the purpose of an impact glove?
Keep from getting your hand smashed.
Keep from getting your hand smashed. Do these gloves have limitations?
Yep.
So if an engine, let's say we were working on an engine and the engine dropped out of the chassis of the vehicle and landed on your hand, will these protect your hands from being injured? Probably not.
I think so.
So really, they are impact gloves, but the design is for mild impact. Small impact, usually like little pinches and things like that a cotton glove or even a leather glove wouldn't necessarily protect you from. What are some other limitations of gloves like these?
Typically can't handle fluids very well.
Slippery. Yeah, they'll soak through and get slippery. Any other limitations of them?
Cuts and abrasions.
Cuts and abrasions. How about shrinkage? Do they shrink at all? Or do they do a pretty good job?
I don't have any problems with them shrinking really.
Good.
I've ever washed them.
Yeah. So that's good. And the only reason I bring it up, because these are some of the best industry standard gloves we've put out there, are the impact resistant gloves for certain jobs. And you definitely want to select the right glove for the right type of work. That's very important. So determine which gloves are suitable for the job from your pre-job JSA and hazards involved. So whenever you start a new task, you want to decide, like Ben mentioned, they're not very good against resistance to liquids or chemicals. It's just going to soak right through. Not your best choice there. There is no one glove that is suitable. You have leather. It's really good against sparks, moderate heat, and really good abrasion resistance. So it's not going to snag very well. Butyl rubber, made of synthetic rubber, protect against a variety of heat chemicals. It's also good against things like aromatic solvents. So we're not working around a lot of those, but it is good. Impact, we already mentioned those, protection of the back of your hand. Nitrile gloves. This is kind of like the oil field standard glove. If you're working in the oil field and you have chemicals, nitrile is going to be your best bet. It's made by a chemical company called DuPont. They have protective chemicals. They have nitrile is a chemical, but in this case it's a chemical that is also PPE. It's a mixture of like neoprene and PVC and a few different types of things. So it's good for protection against oil, greases, acids, caustics, and alcohol. However, certain chemicals will eat right through it. So how would you know whether or not a nitrile type glove would protect you from a certain chemical?
The MSDS sheet of chemical.
That's really the only way to know, is unless you are a chemical genius and you know everything about chemicals. Usually it's just a quick second look through the MSDS. And those are available online. Is that correct, man?
Yes.
So,
and we have hard copies at all of our locations.
There's hard copies around. They're available online. You can see them on your iPad. So really, there's no excuse not to know what type of PPE you need to work with different chemicals. Now, some of the chemicals that you use are pretty straightforward, and they don't change very often. So for that reason, definitely recommend and require selecting the right gloves. Then you have cut resistance, hex armor. A lot of times you're going to have these this is the glove that we showed before, mostly on the palm side of the glove unless you have the 360 model. And these are the types. There's more gloves than this out there, frankly, but these are a lot of the most respected and used gloves in the oil field. Any questions so far? All right. Edge safety when using a knife or other sharp tool, push away from your hands and body. You guys have heard this before. Has anyone in here ever gotten cut while slicing towards themselves? Yeah, most of us have.
Not that we'll admit.
Yeah, there you go, man. Did you know that there's like an insane amount of people every year that go to the hospital from opening that thick plastic stuff that like certain electronics come in during Christmas time? So people get that stuff for Christmas and they're trying to use a knife to open those things up, and a ton of people go to the hospital every year from that sort of package. So if you've noticed in recent years they have like a little perforated thing on the backside that makes it easier to cut this because everyone's going to the hospital. So definitely edge safety when cutting something open, even if it's a cardboard box with packaging tape. You know, don't pull towards yourself when you're opening that up. You definitely want to go away from yourself. Just, I mean, the worst case scenario, it cuts through faster than you expected it to. It's not going to cut you. Carry and store tools with sharp edges or points down. So you don't want to, you know, store, you know, an ice chisel, for example, or anything with a sharp pointed edge upward. And why would that be?
Because if it started to tip over or fall, it would be the last thing to hit with the greatest momentum.
Exactly, and that's a good reason. Now, some of these tools, if you do store those points and edges on the ground, it will damage them because you have all that weight against them. It'll make them less sharp if that's what you want. So in certain times you're going to want to hang them rather than, you know, store them right on the ground. But still, you want the edge down. Keep edges sharp. Dull edges can cause slipping. Like we said, you don't want dull edges on something that's supposed to be sharp. You want a sharp tool to remain sharp. That goes with saws. It goes with cutting tools, knives. So whenever possible, wear protective, cut-resistant gloves during cutting tasks, and that's just going to give you that additional protection. You guys okay with that?
Yes, sir.
All right. Working in heat. This is important. Right now, the weather's pretty temperate. We get some wind coming, and it's even though it's a little warm outside, you can manage it. But come August, when it gets the warmest in North Dakota, it's going to get pretty intense. So some things about heat exhaustion and preparing yourself from working around heat exhaustion. Nausea and or vomiting are symptoms. You also have headache, weakness, fatigue, dizziness, lightheadedness, clammy, moist skin during hot temperatures, or rapid pulse or high heart rate. FR clothing is probably one of the worst things to wear in summer because it doesn't breathe generally very well, and it tends to trap heat inside just because of the nature of the fabric. It's treated fabric, and it has usually it's nitrogen. They surround the fabric in nitrogen, which is heat resistant, which is part of the reason it's good, but it also holds heat in. So if you are wearing FR clothing, what would you do, or what should we do at Capex when it's hot outside and you're wearing FR? What are some ways to cool yourself off?
Hydrate.
What do you say?
Hydrate.
Hydration is vitally important. And do you just want water?
Well, you need electrolytes.
You need electrolytes, which is something that I can't encourage anymore. Is you need electrolytes. You need either Gatorade or Powerade or something like that that has electrolytes in it. So make sure you got a couple cases out there in the field. On the solid side, definitely, because you're in and out of the Connex all day. Does the Connex have an air conditioner in it?
Nope.
No. So they're going to get it's going to get a little bit warm in there. So that's something you're probably not going to spend a lot of time in there during the summer. You're going to be outside. So at the same time, protecting yourself from the sun is pretty important. Your hard hat does a pretty good job of that, but you definitely want to have some sunscreen on as well. If your skin gets burnt, it's going to make it easier for you to get dehydrated because it's sapping water from your body to help heal your skin, which is your biggest organ. So if you start to get sunburned, you're going to get dehydrated faster. So you definitely want to make sure you're protecting your skin. And that's on your face. Mostly you got to worry about it because you are going to be wearing full-fledged FR. What some guys will do to cool off is they'll unbutton their FR down about right here, you know. They'll look like Burt Reynolds out in the field, looking pretty good. And they'll roll the sleeves up. You guys seen that before?
Yes.
happens very often. The thing is that, and I have pictures, when people roll their sleeves up for FR, it kind of, and undermines the purpose of FR, is to protect your entire body in case of a flash fire. So, Texas, for example, 2 years ago, had the longest string of 100-degree days in recorded history. There was 35 days in a row, 100 degrees or above. And the oil field experienced a lot of fatalities due to heat exhaustion and dehydration. And the main change is what people didn't do was they didn't say, hey, it's 100 degrees every single day. We should probably take more breaks. They just work exactly the same, as though there have been no environmental changes. So if there is a lot of hot days, or if it is warm outside, you're going to have to take more breaks. You're going to have to get in the shade more and try to cool off. Is it advisable, on the same point, to walk in and out of a temperate climate set to 65 degrees with air conditioning?
I wouldn't do it.
Going in and out, why not?
I would just get sick from doing it, and I mean, it's not supposed to take that much of a climate change when you're hot.
Yeah. You don't want to shock your body like that, in and out of AC. So that's one temptation that people do have, but you don't want to do that. So, but once again, these are some of the symptoms of heat exhaustion. If you start to experience, feelings like that, definitely take a break.
John, just for a point for the guys in the field, they don't have necessarily access to AC while they're working in the polar tank, but we do have Capex trucks on each location.
Mm-hmm.
So those, as they're able to pull those up closer to the equipment, they could potentially turn that on, put the AC on to a reasonable temperature, and then move in and out of that.
Which is really good. Kind of get that break, rest, be in the shade of the vehicle, and have it cool down. All right, so prevention, we talked a little about this already, but communicate hot weather danger during pre-job hazard assessment, review first aid training recognizing the signs of heat exhaustion, and drink small amounts of fluid more often throughout shift. Always take enough fluids with you to the field. Can't emphasize that enough. Make sure you have a lot of liquids. You don't want to run out of water bottles or Gatorade bottles or stuff like that in the summer. Soda really isn't good for dehydration. You probably want to avoid that as much as you can during the summertime, even though, usually the can feels really nice and cold in your hand, and that kind of makes you feel good. It's not going to be what's best for you. Control. Recognize the signs. Rest is needed. Not overexerting yourself is pretty important. And seek shade or air conditioning to cool down. So I mentioned that, and that's what you should do. Transportation. Be safe on the roads. Ben sent out a pretty important memo was it last week already, or was it the beginning of this week? Last week. He sent out a pretty important memo last week about fatalities in the oil field, and not only the cost of driving accidents, but also, and we're going to get into that here in incident investigation here in a minute, but also the just how dangerous it is. The highway transportation people out here, most accidents they go to that happen on the highway are fatalities. There's very few where it's just a fender bender and everyone's okay. A lot of them are fatalities. The morgue in Bismarck, Williston, and Minot, they're all full. Now people are from this area are having to be shipped to Fargo, which is, for you guys who don't know, it's about 6 hours away, just because they're so full of highway fatalities.
For emergency services?
No, for how many people are dead. The morgue.
The morgue.
They're all filled. Wilson's, Minots, Bismarck, they're all full. So they're all in now, going to Fargo now from this area. So, I mean, if that's not a testament to how many people are getting in fatal highway crashes. This last week, the one in Stanley happened. There was fog involved. There was a slight rise in a hill, and as he went over this hill, as he came down, a truck carrying crude oil was going north across the westbound lane, and two vehicles struck it, and then a third, and then a fourth, and there was 3 fatalities in that, and 2 people were hospitalized. If you drive by that area now, you notice that the asphalt is melted there across the road. They had a piece of equipment, heavy equipment, kind of cleaning up the dirt, but it was a pretty disastrous crash, and that was just recently here. So on the highway, just pay attention. You have to pay attention. If there's fog, we were talking about this last night in a safety meeting. If there's fog, some guys say you don't want to slow down because someone will rear end you. And that's true. Someone could rear end you if you're going 20 miles per hour on a 70 mile per hour stretch of highway. However, if you stay 75 miles per hour and you do rear end somebody, it's going to be, there's not a lot of good chances for survival. So if it's really dense fog, Jonah, what do you think you should do?
I would say go slow or avoid driving if you don't have to.
Avoid driving if you don't have to. Fog out here usually lasts maybe an hour, sometimes two, and then it lifts. So if, I don't know, I think Ben would be okay with just waiting it out for an hour and not being involved in a fatality or a crash like that. So really just think long term. Is it that important that I get to this location this amount of time, or is it worth it to wait? What do you think, Norm? Is it worth it to wait?
Yes.
Most definitely. All right, so going into our next topic here, I promised you we would, so I don't want to hurt anyone's feelings here. Accident investigation and reporting. Believe it or not, especially incidents and near misses, people don't like to report them. Believe that or not. Why don't people want to report things like near misses?
Because they're in a file somewhere and they just keep stacking up and nobody throws that file away and it accumulates. Pretty soon,
Before you know it, it's filled Norm's
paranoid about
office.
somebody knowing about that accident you did 3 years ago, so you don't report it.
You know, people get scared that they could lose their job. Sometimes it's embarrassing, and some companies will actually, you don't want to report it because you're scared you're going to get fired.
It could be used against you. It could be used against you. So you have an option here. Incriminate yourself by filling out this little form, or don't fill out the form and be just fine. So what's the point that's one reason people don't report them. So why does Capex, why is it a good idea to report near misses? Prevent it from happening again. Near miss reports, I've seen different forms. Capex is very simple. It's not even a whole page. It's just a little short one. What happened? What did you see? Some companies call them near miss or safe observation reports, so you can kind of use them as both.
Ours is a near miss and hazard identification.
Hazard identification.
And positive observation.
And positive observation. So that's kind of the intent here. Like Jesse said, you want to avoid something potentially dangerous from actually coming to fruition, or you want to recognize something that's safe. Hey, this person was walking by a hose without a whip check, so he went in the Connex and grabbed it and put it there, so next time they were shut down, they could put it on. Things like that. Hey, that was a safe behavior. Good job. So those are the kinds of things that are the point of it. So incidents and accidents are the main reasons. Does anyone know the difference between an incident and an accident? It's really almost arbitrary. Generally, accidents are things involving people, and incidents are things involving items, materials, things like that. However, certain people are going to describe it differently, and really it's not that big of a difference. All right, accidents. This is the main reason, and this is what Jesse hit on a little bit there, and we're going to go through. This is statistics here. For every 600 incidents with no visible damage, or near miss, for example, for every 600 of those, whether or not people report them, write it in the file that gets to Norm's office, that fills it up so he can't even get in there to have a cup of coffee.
I'm not talking about other people, I'm talking about me.
So, for every 600, doesn't matter if it's all of us combined, if it's company-wide, if it's statewide, if it's industry-wide, doesn't matter. For every 600 of a certain type of near miss, you're going to have 30 property damage accidents. So 30 things, whether it's a $5 thing, a little small dent, a slight backing accident, whatever it is, you're going to have 30 of those, minor. Right? For every 30 of those, you're going to have 10 minor injuries where individuals actually get hurt. Something dropped on a toe, somebody twists their hand or gets it cut. Basically anything that's not going to require hospitalization. This would be in the basic first aid category. And then for every 10 of those, you're going to have one serious hospitalization or disabling injury. So the idea here is, if Capex wide, we have 600, I don't know, what's a near miss that we've seen? We've seen ice, people almost slipping on ice.
Slipping down stairwells or something.
Stairwells, slip, trips, and falls really is probably going to be the most common. If for 600 of those, let's say at 400, we're like, all right guys, we have 400 near misses here. We got to do something about this, so we don't end up with 30 of these. So we can cut that down, and we have a little bit of a stand down or just a meeting. We say, hey, these are some things we're noticing. A lot of people are slipping and tripping, or almost slipping and tripping. Let's get some different type of footwear where it's a little more slip resistant, or let's make sure that we're not walking up and down stairs that are bent and all beat up. Now on rigs, I know it's a little bit difficult. I inspect rigs and they're not always in great shape, and that's a fact. Let's use a trailing hand technique when we walk up and down the stairs to go up to the rig floor. There's a lot of different methods you can use. But the idea here is that as this starts to rise, this number here, you can start eliminating these other ones by talking about it, by communicating. That's the whole.
And you're saying this isn't all injury-free altogether, everything combined?
Yeah, this is just statistics as they analyze how many times does an accident almost happen, and for every 600 times that happens, any random accident, take a certain topic, slip, trips, and falls, for example. For every 600 something almost happens, of that 30 times there is some sort of property damage accident. For every 30 of those, there's 10 of them then subsequently.
And in the oil field in general, that probably goes up a lot.
It could. Yep. This is just overall. Yep. Everything together. And yeah, like you said, there's going to be certain areas where there's going to be more. This is an average statistical analysis here. So we're going to define it here a little bit better. Like I said, it's kind of arbitrary. Accident, undesired event that results in personal injury or property damage. Incident, an unplanned, undesired event that adversely affects the completion of a task. So that's the way that we're going to define it today. Have any of you guys ever had something that adversely affected the completion of a task? Right. So I mean,
Murphy's Law.
Yeah, it's Murphy's Law. It's one of those things that's a little bit difficult to define, and when you're in the moment, you might not think of it as that, but that is kind of what we're working with. Now, near miss. This is one actually I want to hit on. Near miss. Incidents where no property damage and no personal injury was sustained. However, given a slight shift in time or position, damage and or injury easily could have occurred. So, how do you define when a near miss is occurring versus me? What's the difference? How do you know? There's no golden standard. Do you have anything to say to that? So for Jonah, for example, because he's in the room here. Hi Jonah, everyone say hi to Jonah. For Jonah, a near miss might be just barely scraping the guy, right? He was driving his truck and he made a turn into home of economy and just barely scraped the guy's pickup truck. Near miss. Could have been worse, right? For me, a near miss could have been I was about to turn and a truck driver pulled out in front of me and I turned to avoid him, and had I been looking down, I might have had 50 feet. But had I been looking down or texting or doing something, not paying attention, I would have had an accident. And there's a difference of 50 feet between Jonah's near miss, perceived near miss, and my near miss. The reason I bring that up is because this is a little difficult to define, And what I'm going to challenge everyone here at Capex to do is to really think about what a near miss is. And in general, it's something where if you're given a few seconds or less attentiveness, or if conditions would have been slightly different, there would have been some sort of damage, whether it's a personal injury or damage to property. And I would also call it a close call, a near miss. Some people kind of make fun of this and they say, wouldn't that be a near hit, not a near miss? How do you nearly miss something? But yeah, that's kind of... So what I really want to challenge you guys to do is think about it and report them if there is something out there, not because it's going to make you look bad, but because we want to be able to stop things from happening in the future. All right, so obviously some negative results of accidents or injuries. You have physical harm, minor, serious, it's reportable, compensational, disabling, lost time, and then you have death and catastrophic. Does anyone, well, in the industry, we determine A death is a fatality, and a catastrophic is multiple deaths. And then in property damage, you have property damage, and then you have a catastrophe, which is usually $1 million or more in damage. So catastrophic, those are kind of the terms there. Property, minor, serious, major, or catastrophic. Family, the sorrow associated with loss of parents, children, loved ones, and friends is pretty serious. Have any of you guys ever seen the movie, or it's kind of a presentation to Remember Charlie? You guys ever seen that before? There's a guy named Charlie. He was working in a gas plant facility where they process natural gas, and they had invented a time-saving technique to process the gas, where they bypass certain safety mechanisms. So they would, there was this filtration system where it kind of slowed down the process, and it took about, I think, a couple more hours. So they just bypassed the process. But some of these valves, they didn't have a preventative maintenance plan, weren't working properly, and they weren't inspected. And he ended up getting some gas on his clothing, and opened the valve up. The gas followed him out to his pickup truck, which found an ignition source in his vehicle and exploded. And because he had all the gas and stuff on his body, he wasn't wearing FR clothing, and he was burned. I think he had somewhere like 60 some surgeries later, and now he travels around talking about, hey, wear your FR clothing, make sure you're doing things the right way, don't be skipping steps and cutting corners and things like that. People who go through that, the sorrow that their family has to deal with having a loved one in the hospital for 60 plus surgeries and being horribly disfigured, it's not just you as an individual that's going to be affected, it's going to be a lot of people that are affected by accidents. Obviously, the unexpected and undesired hardships of having a major breadwinner not being able to work. The physical pain and discomfort from injury, which is most people's incentive not to get hurt. Nobody wants to get hurt, no one wants to go to the hospital. And the psychological problems. This is especially apparent with athletes. Athletes who get hurt even playing the game and can't play anymore. I mean, it psychologically affects them. Guys who really take a lot of pride in their job and their work, and they can't go to work anymore. They have to sit at home all the time watching soap operas. That affects, your psyche. It really does. So you have a lot of reasons not to get hurt. There's some adverse costs. I'm going to move through these pretty quickly. Insurance costs, medical, compensational, building damage, tools, equipment damage, production delays, product and material damage. These are all from the production side, just adverse side costs. Uninsured, when people are uninsured. And Capex does have a pretty good insurance plan, if I remember so. All right, fatalities and injuries. Fatalities on average cost $4.5 million. A lot of people say, well, people's lives are priceless, and I agree with that on the human side, but when you actually quantify the number of what it costs when someone gets killed, it's $4.5 million. The reason I like to focus in on that is because people, when fatalities happen, a lot of times time or rushing a job is one of the factors. People getting through a job quicker. Save time, save money. Generally, you're not going to save $4.5 million by getting that job done quicker. So if you ever have the inkling, if we do this a little bit faster, even though it's more dangerous, we'll save money. Probably not. Injuries, on the other hand, all injuries combined together on average run about $250,000. So that's whether it's a small, stitch to your finger or something a little bit more serious, about $250,000. All right, so there's something called RCA, besides the electronics company. They use it in the safety world. It's root cause analysis, and it's where you take an accident and you kind of follow it through and say, why did this accident happen? What were the contributing factors? Fatigue is the main one in the oil field, especially in driving. People being overtired. People having to drive after a long shift or drive before a long shift and not getting a lot of sleep the night before. Those are a lot of contributing factors in fatalities on the road, for example. Other things that can be involved, you have people with a lack of knowledge or skill, people being improperly motivated, physical or mental problems, job, task, or factors. outside of the individual themselves. You have inadequate work standards, inadequate design or maintenance, normal wear and tear, or abnormal usage. Using the wrong tool for the job. Forrest, I don't know if you've ever been forced to do or have seen people do something like that before. Using a wrench as a hammer is a great example. You got a hammer over there, it's across the shop, you just need to hammer something in real quick. Well, you got a wrench right here, and then you use it to bang it. I mean, it happens. Things like that happen all the time, but those do contribute to accidents. Job tasking factors, a few other things. Slip, strips, and falls. Jonah brought that up before. That's our walk-in working surfaces. Capex does an incredible job of having good housekeeping. Of all the companies I've worked with over the years, housekeeping here is it's 9 times, if not 10 times better. Inattention. People not paying attention to the task at hand. Doug Syme, if you ever talk to him about people being attentive in the field, he'll tell you that the way somebody eats their Cheerios could affect your psyche, you being focused on a job and being frustrated. And it's true. I mean, little things in your life, your personal life, can affect your attentiveness to a task. Fatigue, I mentioned that a little bit, and obviously drug use or being under the influence of alcohol and things like that. The one right next to there, we have lack of training. Lack of knowledge, new to a position or company, or changing standards or methods. People not knowing how to do something, but wanting to pretend that they do so they don't look unintelligent or stupid. They'll do dangerous behavior. All right, we have substandard practices or conditions. That can always happen. Unsafe actions, they're violations of accepted safe work procedure, which could allow for an accident to occur. People not doing things the correct way or the desired way. Then you have unsafe conditions, where people are working is not safe for whatever reason. They don't have the right tools. Their tools are junk. Even out in the field, if your centrifuge is junk or your shakers and you're always having to take them and refab them or fix them up because they're breaking down, that over time will create an unsafe working environment because you're always having to work with iron and move stuff around. It adds time to the job. So having the right equipment as well as having the right workplace is important. All right, there's a systematic approach to RCA or root cause analysis. You have people, who's involved. And if a certain individual is always involved in accidents, that's generally a sign that something needs to change with that guy. Environment, where they're working. Procedures, what requirements do we have for doing things the correct way? And then lastly, equipment. Capex, and whenever I talk to guys out in the field and they say why they like to work here, a lot of times, this will always come up. Equipment. They have great equipment. It comes up time and time and time again. So having the right equipment is important not only for safety, but also for liking your job. They also say like the people. The work environment is good. This policies and procedures one, a lot of people don't say, oh man, the policies here are just awesome. Man, I just love them. But believe it or not, this is usually behind a lot of these other things being done well. Is people having an idea of this is the way we're going to do things. Regardless of environment, regardless of the people around, regardless of the equipment we have, this is how we're going to do our job. All right, so this is a little bit more of how that fits in, and that you have always the outcome, the effect. All right, so lastly here we have recurrences, trend analysis, which is a little bit of that statistics I brought to the table earlier, that triangle, people following trends. JSAs, being able to plan the job. Training, how much training individuals have. Capex likes to hire people that have some experience and not bringing a lot of new people on as a rule. And part of that reason is because it eliminates risk factor. People kind of understand the hazards of the job and they're not making a lot of bad decisions. Protocol, we talked about this a little bit. Lastly here, if there were to be an accident or an incident on a rig, for example, worst case scenario, and the media were to come out and start asking questions, you probably, guys in the field or people in this room here, would probably want to deflect them to your public information officer, which would probably be Ben Schaefer in this case. Say, hey, you want to know about this accident and how Capex was involved? Talk to Ben. Because the last thing you want is a guy on TV, you know, Capex hat on, oh man, it was crazy. People were running everywhere, there was pipe. You don't want to do that. You want to, we'll talk to Ben, and Ben will go ahead and address the media appropriately. So also you do want to take notes, take pictures if you do see things that happen, because what happens eventually is people come out there and start moving things around. If there were an accident, that was your accident. That wasn't Jonah's accident. That's just my
Southern redneck voice.
I have nothing to comment on. All right.
That was a derogatory slang.
All right. So
Jonah
last
hasn't
week,
done anything either.
that was actually my Cops voice. If you guys have watched a lot of Cops, Jonah, have you watched a lot of Cops? All right.
A couple of them.
Couple episodes.
Are you talking about TV?
Yeah.
Oh,
That's exactly what I'm talking about. All right. So. All right, behavior-based safety. Have any of you guys heard of this before? Is this kind of a new term? Just reading through it a little bit, you probably get an idea of what it is. What is behavior-based safety? Well, all right.
Why don't you teach us?
All right, we'll get at it. Behavior-based safety is just essentially safety based on behavior, right? So it's not rocket science there, it's pretty straightforward. How people do their jobs, where people stand when a job's being done. If I'm working on something and somebody's standing in the wrong place, can that make the job more dangerous? What do you think, Dorn?
yes.
Yeah, most definitely. That's one example of people being in the wrong position, people using the wrong tool for the job. We mentioned that a little bit before. People rushing, that's a behavior. How do you guys work, for example, when you're angry? If you're upset with somebody or something and you're working, how do you generally work in that situation? Aggressive?
Distracted.
Distracted? A little bit rushed or kind of scatterbrained, maybe not as organized as you'd like? How those things affect your job, that all kind of falls into behavior-based safety. So the process that helps employers and employees that understand, identify, and choose a safe behavior over an unsafe one. Fog, not driving in the fog, for example, that's a choice. That's a behavioral choice. Hey, it's foggy, I'm just going to pull over and wait for the fog to lift before I keep driving. It's important to know not only what the unsafe behavior was, but why the unsafe behavior was exhibited. Why do we do things unsafely? Why do we choose time over safety, for example? So you have three measurable components here: the person, the environment, and the worker's behavior. I don't know if you guys ever seen this photo before. These guys walking around the skyrise. It's now being tied off. Pretty scary. When these three components are brought together, we can identify and eliminate workplace accidents. So we're looking at the following. We have workers' physical capabilities. You know, are they capable of doing the job? Plain and simple. Workers' experience and the extent of the workers' training. Are they knowledgeable? Have they been brought up to speed, or are they just kind of winging it? You know, and certain things you can get away with winging it. Taxes, for example. You just wing it, and if there's a problem, you just throw in some numbers, no big deal, right? Right, Chris? That's the way those work.
Try that out. Yeah, it works.
Other things you can't get away with doing that quite as well. For example, a driveway, putting in a driveway. You can't just wing it, because the next spring, when Jonah's trying to drive his truck up on the driveway, it's going to crack and fall apart. Right, Jonah? All right. Sorry to stab you on that one. The environment looks at a few different factors: existing or potential engineering controls, equipment, job work tasks, and the existing workplace culture. How do people work together? If everyone hates each other on the job site, you have a problem, because no one's going to communicate. if something dangerous is happening, it's probably not going to get passed along. We could walk through that picture. There's about 100 things going wrong in there, but yeah, it's a pretty dangerous job site. So, final, often overlooked component of all that stuff, which we all kind of know intrinsically, probably haven't put names to it all and thought it through and wrote it down on paper, but the worker's behavior while on the job, this is a very important tenet of all this. How individuals behave, how they work. Behavior is defined as the way in which one acts or conducts oneself towards others, and the way in which a person acts in response to a situation. So, for example, one of my favorite ways to bring this up is how people respond to criticism of their job. If someone tells you, hey, that's not the right way to do that, or hey, maybe you could try doing it this way better, or no, stop, you're doing it incorrectly. How do people respond to that? Everyone responds differently. Some people get offended, other people say, oh, okay, great, yeah, let's do it a little bit better. Some people get quiet and don't say anything, and they get frustrated or angry or upset. And everyone's a little bit different. How we respond to changes in work and other people working with us is all kind of, funnels down into how people, their behavior when they work. So process has 4 components. You have behavioral observation. Capex does this when they go out and do evaluations. This is all tracked into it. People are watching you, whether or not you know that. They do. We watch each other. It's just part of being a human being. A formal review of observation data. So looking through all that data and saying, hey, Norm has 600 near misses here in the last month. What's going on? Not that Norm would do that, but he could if he wanted to. Improvement goals. This is the part that I really like about behavior-based safety. The idea isn't just to find problems. The idea is to find solutions to problems if there are issues out there, and then positive reinforcement to achieve those goals. So observation and feedback, you have direct, measurable data. No one got hurt this year. That's a direct, observable number. Observe routine tasks, record both safe and unsafe work behaviors, which comes into the near-miss reporting, and then provide positive feedback for safe work behavior. Some companies give out bonuses. Other companies, have picnics and things like that, safety stickers. There's a lot of different things that people do, or just encouragement. So reviewing that data, a lot of times, it's easy to tell if people have been hurt or not. But sometimes on the job, even if you're bitten by a bug, that would be an on-the-job injury, if that were to happen. Improvement between observations can be graphed to show visual improvement. Then you want to set goals. They need to be attainable, realistic, and forward-driven. So if next year we say we want no automobile accidents in Capex, United States, 0, no auto accidents. Is that an attainable goal? Definitely. So you set that goal and then you figure out how we're going to do it. Well, we're going to try to have our first move forward. That's one method of achieving that goal, for example. We're going to try to give other people the right of way. If there's ever a question of, either merging or stop signs or anything like that, we're going to give other people the right of way. And we're going to wait our turn in line. We're not going to try to rush to get to where we're getting to. Those are some ways to reach that goal, for example. So you have percentage, process goals, improve the way we do our jobs. And then lastly, implementation, improve what we use to do our jobs. And a lot of that's when Capex goes around and asks people, hey, how could this Econics building get better? And then them implementing that, that's exactly what they're trying to do here, is improve the situation. It starts at the management level and then it comes down to the worker level. It has to start with management. If not, it's always just going to be kind of a conversation. It's never going to be action. So providing immediate positive feedback and rewards. And the workers need to encourage other workers to work safely. You don't want to be a jerk about it, but it needs to be on all levels. And these guidelines are definitely going to lead to improved efficiency, effectiveness of the work, productivity, positive morale, and lastly, profitability. If you have a company that works well, you're going to be saving money. So that's about all we have for the day on our topics. Are there any questions in the room? All right, for people watching on the YouTube here, you can, if you have any questions, go ahead and put them in the comment box, and we'll answer them in a decent amount of time. So that's all we have for the day. Thank you very much.
Thanks, John.